Okay, so welcome to this session. It is the data products and tools. It's a flash talks lightning round. So they have each 5 minutes and they've all agreed to stick to 5 minutes. So first up is Thomas Huang.
Hey. All right, I'm Thomas. I'm from JPL. I might talk fast because this is a little bit higher than where I stay, Salt Lake City. So I am. Did you project my slides? I have to. No, this is not my slide. Oh, I have to click on it. Duh. Okay, so I'm a principal investigator for one of the NASA projects on building an integrated air quality information solutions. It's actually a bigger part of that effort is to build a digital twin for air quality. So, and the whole point is to, first, many of you have come to me during my poster, is we want to create a solution where we have a one-stop environment with satellite, in situ, and model, and ML predictions all in one place. And you can access this as a platform to look at all the data, compare them, visualize them, generate animation out of them, and then use this observation, we can drive our next predictions. The prediction can help us to drive our next observation, which then hence will enhance our next model execution, right? That's the grand vision. But what I'm showing here is today is the platform that we have created is you don't have to take a cloud class for this, and you don't have to take a Python class for this. Last time I signed up for my Google email account, I didn't do cloud certification, so I'm not going to preach you about cloud. But everything is do simple RESTful API, so you can talk to the system, do simple like MATLAB and IDL, or your favorite Fortran programming language. I'm a computer scientist. I'm just grateful to be here with all the smart people. So just in a nutshell, right? We created this as a platform and not selling you a tool. I've been building software for a long time as an open source advocate. There's at least 30 NASA software package with my name associated to it, and I'm still going. So we create as a platform means that everything is through a simple API. So to demonstrate this platform, we built a couple of applications. We have interactive tools that you can actually run it through your browser, look at different satellite observation, model outputs, in situ measurement, do the interactive analysis and compare them. We have the work that we work with Christine and Mohammed and folks like that to do the predicting more debris. So we generate daily prediction on the air quality for Los Angeles. You can query our system for that. We have the solution where you can generate the animation visualization of the satellite measurement. So this is actually an example of the smoke from the wildfire from the Canadian side. And then finally, just for kicks, we say, well, we have a data-rich platform. Can we just do our VR on top of it? So we did. So you can go to a one-stop website to see all of that exciting tools. But more importantly, we expose this simple open source solution so you can download our Jupyter notebook to play with our APIs. So again, these are some of the animations that you can generate from our system, but also do the interactive analysis on this, let's say, for the Canadian wildfire, and pull the measurement from the, let's say, like for New York City, what's people actually breathing for that day. The same analysis you can run through our interactive tools, same analysis, same data, same visualization. Now you just have a different environment. And recently, we also added greenhouse gas to this. So why not, right? So we added the CO2 measurements from the OCO3 missions. And you can actually do some analysis, look at what CO2 looks like for LA during COVID and after COVID. You can also look at some of the smoke, the methane plumes from the emit interactively. Everything's done on the fly. You don't have to download all the data. So recently, this is actually fresh. This is actually something delivered from my engineer yesterday. I was like, can you just take the CO2 data and just do a VR environment for us? Like use the same platform to power it, but now you can have this full immersive. You can look at the data from top, but you can overlay this with things like a ground measurement and anything in between. And now you can have immersive, fully infinite workspace to do your analysis. And so if you look at the CO2 measurements, from LA and also from Wuhan, China. And this is the same data that you used for that whole notebook that I shared earlier. So again, you know, I'm running out of time. As a big advocate, open source guide, I'm really active on working with the community and coming to, meeting with smart people like yourself. One thing that I really encourage everyone's looking at, and what John mentioned the other day, yesterday, about this whole Earth science to action, is like, how do we get us all so good to work together so that we can help a decision maker, right? So my job is really try to work with you and figure out how do we connect your research, your model, your analyses, and they can work together to the point where we can actually digest to something that the decision maker can actually take actions, right? So that's what I envision. So every single one of my project, I work with the science community. So I don't go and preach technology. I just have the scientists to change for me. That's the best part. And we share everything. We open everything. The platform is open to the public, and then we have and we partner with the Apache Software Foundation. So it's not just partner the GitHub. So finally, you can go to this website. You can find out more about our project, and you can email me if you have any suggestions or recommendations.
Well, next up is Sarah. Is it Hafer-Martin or Hafer? Hafer-Martin. Okay.
Right. Hi, everyone. I'm Sarah Martin, and I am with the Atmospheric Science Data Center. We are one of 12 DACs, which for simplicity's sake is a data center for Earth science data. To get started, I'm just going to show you the ASDC website. Every DAC has a website. Today, I'm only going to show you the ASDC one, but it's pretty easy to find the other DACs if you are looking for them for different data. On Earth Data Search, right at the top, you can select Find a DAC, and the link will take you right to their website. This is just an easy way to find them on a website you probably already visit for downloading data. It's a data center. It's a distributed active archive center. So this is the ASDC website. Again, you can find other DACs pretty easily at the top if you're looking for something different that the ASDC doesn't have. The ASDC has atmospheric data, but other DACs also have useful data sets for health and air quality too. I'm only going to focus on ASDC again, our tools and services today. I'm going to walk through some of them, but you can find all of our data products under Find Data if you want to see what we host at the ASDC. After you select selected tools and services, you'll be brought here. There's a very long list of tools and services that the ASDC provides. There is a filter at the top so you can narrow down what you are looking for. I'm only going to focus on two today. That is Subsetters and the Earth Data User Forum. There are a lot of other services, including data visualization tools that I encourage you to explore on your own. Today, I'm going to show you the Calypso Subsetter, which is right in the middle there. It's a very popular subsetter, but all of our subsetters are extremely similar. So I'll show you one, you'll be able to walk through the others. There also is a tempo subsetter coming as well once tempo is available. So you do need to log into Earth Data. It will automatically take you to the login page when you select to use the subsetter. This is what the web app will look like, and it's different than just a search tool. It will search all the Calypso parameters that you're looking for, but it will actually cut down the data. So you're only downloading the data that you need. So you're downloading a much smaller data file instead of downloading the entire data set. First, choose which data product you want, then the variables you need. Just choose it on the left and hit the add button. Certain variables will always be included in the default because they're necessary for the data product to be readable. Again, the file you download at the end will only include what you select. So if you don't select a variable, it will not be in the file that you download. First, you choose which data product. Next, you choose your date range you want downloaded. Here, I chose just a few months for example purposes. Then you can subset geographically. So this is the part that most people are really interested in. This will cut down the data to the geographical range that you choose. So you won't get the entire data swath. You'll just get your area you select. You can draw a box, input lat long points. And some of the subsetters, you can also use Esri defined regions. Not all of them offer this, but this allows you to select something like the entire state of Virginia and it'll cut to that shapefile. Not every subsetter, again, has the Esri feature. So just be aware of that. You can see at the bottom left here, it's telling me how many files it's found based on my parameters. So that's the number of files it is going to subset for me. You confirm your request, hit OK, and you'll get a file list. When you submit this to the ASDC, the request will be for the files in the list subsetted to the specific parameters. And then you'll receive your subsetted data from the ASDC based on the parameters you had already put in. Okay, moving on to the Earth Data Forum. What's cool about this is you can ask a question about data from all of the DACs in one place. There is a link on the ASDC website under user community to access it. This is just a quick access point. There are other places to find it as well. This will take you to forum.earthdata.nasa.gov. There are two main options when you get here. One is to post a new question, which I'm not going to show you. It's pretty self-explanatory. You just hit post a new question. And the other is to search what is already on the forum. You can either type right in the search bar what you're looking for, or you can use these tag options that we have. There are a few categories the tags fall under, and you can select what you are looking for. It's especially helpful if you're looking for general information on a data product or topic. If you have no idea where to start, you can just search by your data product. Here I selected 3 tags in this situation. Maybe I'm having difficulty processing my atmospheric data. So I'm not sure exactly where to get started. So I selected those 3 tags to just get myself started and then search what we've got. When I submit it, it'll take me to a post that has, take me to a page with every post that has these 3 tags on them. You can do more specific than this. You can refine your filters even after you search if you realize you're getting too many results. What's great about this, though, is that subject matter experts from the individual data centers that handle the data products are the ones responding to the questions you have on their data. What makes this a little bit different from the HAQAST forum is this is pretty good for data-specific questions you have that can also help with the actual data retrieval process if you're having problems with that as well. And that is all I have. There is a poster I did with more detail on this, and that should be online with HAQAST.
Or Judd, you're up next.
Great. Hi, everyone. I'm Laura Judd. I work at NASA Langley Research Center, and in the spirit of thinking about data products with these flash talks, I wanted to give an example of an activity we did this summer with the Airborne Science Program at NASA. So you've heard a lot about TEMPO this week, and to align with TEMPO's first flight and the first month of measurements, we actually conducted a large airborne field campaign this summer. It was called the Synergistic TEMPO Air Quality Science Study, or STAX. So the logo for STAX really, in the name in itself, really describes the observing strategy needed to really understand our air quality issues at the top. We've heard a lot of examples this week about using satellites to understand our air quality challenges, as satellites give us this broad overview and kind of close the gaps between maybe monitors that are near the surface. During STAX, we also deployed, thinking about the surface monitoring networks and deploying some enhanced measurements, we deployed a number of tropospheric ozone lidars in areas of the country, including New York, the Lake Michigan area, and LA. And the part that I know the most about is really about the airborne assets that we deployed that kind of closes that gap between the satellites and ground measurements during these field studies. And thanks to folks this week that have shown some highlights from previous studies, including Dan and Parlene and Michael Geigert, of some very good examples on how this data can be used in conjunction with ground measurements and satellites. So we just wrapped up about 6 weeks ago. And so I thought I'd share a few pictures. I'm assuming a lot of you haven't been on airborne field campaigns, but this is a group picture of our 3 airplanes and the group. And so for STAX, I was largely in charge of the 2 left airplanes, the 2 Gulfstreams there, and we're focused on remote sensing measurements. So thinking about satellite proxies on an aircraft. And we partnered with NOAA, who deployed their NOAA Aroma project, and they used the NASA DC-8 which is a very large airborne platform for doing airborne science. So a little bit of a look inside the aircraft. This is just in the Gulf Stream, so you can think of the DC-8 might be something like this, but on steroids because it's a much larger air platform. We have our instruments that are installed in the case of remote sensing over these windows that are in the belly of the aircraft. So you can actually see the coffin of an aerosol ozone LiDAR called HSRL-2 that is on the G5 right up front there. And in flight, we're sitting, you know, behind these instruments at the instrument racks, operating them, making decisions in flight. And we kind of get the best view, I think, in my opinion, our office view for the day when we're out in the field. This is two perspectives where the top is from our the NASA G5 at 28,000 feet. We're actually literally lawn mowing over cities, mapping. You might have seen some examples, and I'll show one here in a second. A great piece of information to add to this remote sensing efforts are the in situ data where the DC-8 actually flies low where the pollution is and actually ingests the air into their instruments and measures that directly. And so they get a little bit of a different view and they get a little bit of a different attention. You might have saw some really cool media stories this summer of this NASA plane flying very low over these cities. So one of the most exciting things in connecting with Tempo is where were we on first light? So this is a video you probably haven't seen yet of first light unless you've been on the SBS website. On this day, we were actually in Chicago with our 3 aircraft. Let's see if this pops up. So this is just an example of some of the maps that we collected where we sample over these cities 3 times a day. This is GCAST preliminary NO2 slant columns. I'm working over the next month to convert them to vertical columns for use and make them publicly available as soon as possible. But the exciting part, I think it's exciting, but maybe it's unfortunate for folks breathing the air on this day. It was actually a high ozone event in the Chicago area. So it is fortuitous because this does happen, and we actually were able to get some enhanced measurements on that day. And what I've learned during these field studies is in the morning, the spatial distribution of precursors can actually tell us a lot about what's going to happen in the afternoon. And in this case, you might be able to see it, though I covered it a little bit, but you can see the Chicago precursors going out over the lake. And if you looked at the monitors, it's all the monitors along the shoreline that actually exceeded the ozone standards on that day. So this is just my last slide. I don't have more data to show because we're still actively presenting or processing data, but this shows where we went. We went to Los Angeles, Chicago, and New York. The yellow dates actually indicate when we measured with Tempo. So we have about 10 days, 10, 11 days where we overlap with the satellite measurements. These data will be publicly available through ASDC. And largely, if you're looking to use it, I would recommend the SOOT tool. And I learned today that there's a presentation online on the HAQAST website where Nathan from ASDC put together talking about how to use this tool. So looking ahead, we're actually looking to use this data very soon to help validate Tempo observations. And so I'm hoping that in June, we'll be able to share some results on that.
Well, the next up is Greg Osterman, but since you're up here, Doug Boyer.
Hey everybody, Doug Boyer from the Texas Commission on Environmental Quality. I'm not going to talk about a cool data set or tool. Really, I'm going to talk about sort of stepping back and the considerations from a state air quality decision-making agency and perhaps sort of what things that we may need. So I'm going to go through this quickly, but the first thing is that we are required to be doing things to the federal requirements, restrictions, timing to that. And so everything that we do is focused on that. All of that was sort of built in the 70s, 80s, 90s, a little bit after that, but it did not include operational satellite air quality. So everything's based at the nose level, the instruments on the ground. So keep that in mind. From Texas' point of view, I can say that our resources are strained. There's a lot of things going on. We have a lot of SIPs that we have to deal with right now. There's a lot of other rules coming in at the same time. We have to analyze and figure out how those impact the agencies. Zach mentioned there's a lot of capital coming out too from EPA and other groups. Well, you got to figure out how you're going to deal with that. So we don't have the time to go and look at new data sources and figure out how to incorporate those into our industry. need some help. Every agency is going to be different. And so consider asking, figure out what's needed. Let's start a dialogue. And this sort of all came about from looking at this Unbound report that I saw in a HAQAST email. And I thought it was a really great report talking about how to reduce these barriers from NASA data sets. The first thing that really pops up in my mind is this acronym that they use. First off, that's a barrier to me. NASA is the leader in acronym development, but that is an initial barrier to a lot of people. So think about that. This is a great thing. I wasn't involved in this, but I'm just, sort of talking about the report. 3-day workshop. They had like 24 different data users from all of our facets of our communities. And the bottom thing I think there is important. So the biggest challenge users identified using this air quality data was data accessibility. We can all think about that in different ways, but how do you get to it? How do you use it? Okay. The 3 workshop days were of these questions. Think about this in your work, your tool, your research paper, whatever it is. But can X user, whoever it is, can you find the data and download? Next step. And then you open and understand the data. Those are very 2 important things. We heard about some ways to do that in just these talks. The last one, fine, you got it, you opened it, you think you understand it, you can actually apply it to different questions. These are sort of the main outcomes that I took from the paper, but it is really important to get. I'm not going to talk about the red quotes, but yourself. The first one is use plain language, and Jerry and I was one of our Tiger team discussers earlier today. This is really important. If you don't know what that means, it's just, hey, try not to use technical terminology describing what it is. Try and not use acronyms. A lot of journals are now requiring a plain language description of what your research was. And that's very important to broaden the use and sort of soften everything that we're talking about so it can be digestible. So including in that, it's if you have data, put it in file formats that others are more familiar with. So we heard about GIS, I think almost every single session. So consider that. We saw that too. And then Tracy talked about her tutorials on the website. Consider offering code snippets. Some of us do have coding capabilities, but we don't have the time to go and build up code to analyze our data and bring it into looking at our photo. So consider having some code snippets there that we can use quickly. The biggest talked about being able to subset data. I think that's really important. But also the metadata up front. We don't want to see a list of files that we have to click, download a 4.5 gigabyte file, and then figure out what doesn't have that variable. So put that information up front so all of us can understand what's in it. Is it useful? We all have different hardware, software, and internet capabilities. So consider that as well. And the last is consider other current analysis. NASA's, I say the whole ecosystem is awesome, and there's so much information out there, but it's too much information, and every website has its own data and different things. So perhaps consider putting your data out in some of these other places where people are typically going to live or provide other information. So just some considerations for us to all think about. We have this, we've given them our data too. So
up next is Greg Osterman.
So, hi everybody, I'm Greg Osterman, JPL. So I have way too many slides, and after the previous talks, I want to give a completely different talk. But I'll go with what I got. So I've been at JPL a long time, and one of the things with JPL is work on a mission, and then you get a different mission and come back to it. So I've been in and out of the atmospheric chemistry area for a while. I was around with the original HAQAST. I just want to say it's amazing all the progress that's been made over the years. HAQAST, HAQAST, still following. Anyway, just want to say that. So when I joined JPL, in 2001. Okay. Okay, sorry, better. All right. I started off on the test team, the Tropospheric Emission Spectrometer, which flew on the Aura satellite with OMI and MLS and hurdles. Test no longer works. It's been out of commission for a few years, but out of test came TROPESS, and where we took the test retrieval algorithm and what we learned from that, and we kind of expanded it, improved it, and are now applying it and using different data sets from different satellites that are flying right now. It's like AIRS and Chris and OMI and Tropo. So acronyms, TROPESS, I couldn't tell you what TROPESS stands for, but it's a complicated acronym, but it's in there somewhere. But TROPESS, there's a website at JPL. We are creating a data set from these different satellites. We have ozone, carbon monoxide, ammonia, methane, PAN, HDO, some new things there. So but the one thing about working with AIRS and Chris, we can go back in time, back to 2002. So we'll have the information going back pretty far, and we're doing it in a consistent manner. So the different satellites are all retrieved with the same retrieval system. So the errors are the same, get averaging codes for people, which you may not care about, or shouldn't, but I'll mention anyway. So these are some of the satellites that we are working with. Like I mentioned, Chris, AIRS. We have a combined AIRS OMI where we use both of them together to create an ozone data set. We have a forward stream. Just heard about the DAX. Our data is available at the Goddard guest disk. If you go to the guest disk, these are just an example of some maps of CO from our products, but and TROPESS, you'll be able to find the data. Yeah, so we have a forward stream that's available now. We're doing retrospective processing, which will be available. And if you contact us, we can help you get the data. We have special products, like we have some data sets focused on just specific megacities. This is a partial list of the cities, and those go back in time, but just data in the box around this city. We have some from fire as well. There's some links here. All of this was on my poster, which is out there, which you should have access to through HAQAST. If you have any questions, feel free to contact me or reach out to me. We can help you with this. But as far as accessing things go, we're trying to make that easier a little bit. We're developing some Jupyter notebooks where if you have some Python capabilities, you'll just run the notebooks, get the data, bring it in, and visualize it. We're developing more of those to try and make things at least a little bit easier. It's a big data set. This is just one example of some of our data. It's our CO column for this CO Canada and over North America for the past years. You can see differences with different years of fire. And lastly, we have, as part of our group, we have Kazuo Miyazaki, who runs models for us and has developed or has a library of model results going back to 2005. Simulation, and that's also available at the TROPESS site. Yeah, this is our team. Thank you.
Okay, so we'll just have a few questions, but I will say one thing is I've worked at NASA for 20 years, and during a few of the talks, I was feeling a little overwhelmed myself on all that was being presented. So I recommend anybody who is a newbie, not very tech savvy or just has no idea where to start, go right to the HAQAST website. There's some information there about how to get going using satellite. So it's a very useful resource. Okay, any questions for the speakers? Excuse me? Okay. Okay, are there any questions for the presenters?
I do want to make an announcement about the there's the virtual flash talks. Laura shouted out the one Nathan Jesters, if you're interested in that. There's also, if you're brand new, like Bryan mentioned, there's a good talk from Elizabeth Joyner on the new NASA Pathfinder to help you figure out all these different data sets. And there's also one from Kristen O'Korn about low cost PM 2.5.
So this is, I guess, a question for anyone on the panel. But I think that there is this sort of cultural divide between the NASA data product developers and data users. I mean, in really almost any community. And what are some mechanisms? I mean, of course, we have HAQAST, and we're trying to be a bridge and having conversations. But what are other mechanisms that can help build connections, change, like make the cultures more aligned with each other? And, I think one, and Bryan and I were just talking about this earlier, is like, well, there's this phrase capacity building, but that really puts the burden on the users to get up to speed on the way NASA does things. And I guess I'm curious, like, what can NASA do to, again, like not just developing a new website, but like making it more accessible?
But I talk about a website that so I've been managing the NASA Sea Level Change Portal for about 6-7 years now. So if you haven't been to Sea Level Times, go visit that site. It's actually a site actually developed for different types of audience. Right, you have the public engagement, people who actually want to know what is causing the sea level rise, to the point where researchers want to find what relevant data is available. Right, so how do we build that? Right, we besides just having these education material, like engaging the public, but you also create one platform where you bring in data and analysis, and we have the sea level science team, just like HAQAST scientists, right, providing their research, and we put them into one place. And imagine being able to not going to a download immediately. I worked for the tech for like 15 years. But imagine looking at the image of NOx and generate a time series, look at it and say, hey, remove the seasonal signal and see if there's a spike. Instead of looking at 10 years of data, now you window down to maybe 6 months, and now you go to download. I think that is significant, right? That saves a lot of time, unnecessary downloads. And then really the goal is, my job is not to do science. I'm not a scientist, I'm not as smart as you are, but my goal is just try to shorten the path and help you guys to do the real science instead of thinking about replicating data wrangling. Download data, recruit the data, subset the data, like everybody's doing the same thing. Like, why are we doing the same thing over and over again? So having some solution, maybe HAQAST was a good place to think about, is having one integrated environment. It's not just sharing your publication, but getting all the interesting research and product to put together and present to you.
Say amen. Okay. Any other questions? Okay.
To follow up on that, so we've heard talks earlier yesterday about the EPA remote sensing information gateway, which is a nice example. It's definitely tooled specifically for EPA and CMAQ users, but it is pulling from all these different DACs and ADC and DIS and et cetera with APIs and bringing it to the user. And Doug talked about reaching out to Google Engine, AWS and things. There's a whole new landscape where I think probably many of you are getting data from these cloud services. I know NASA and NOAA are looking at cloud services in the future. We should be getting that data out there now. I was recently, we had to get lots of acronyms, per data in GRIB2 format, blah, blah, blah. We've all done that are researchers. And then it's like, oh, you get it on AWS and there's already apps and it's easy to use. So I think we need to be embracing that in addition to the formal DACs, which are the data archived, right? But there's other ways to get it to the users.
I'm not sure if anybody from ASDC is in the room or not, but that is the direction that they are going with the DACs, and doing cloud services and things. It's just a very long and detailed process, but they are working on services in the cloud, and it won't be any more difficult to users or anything like that. You won't even notice really a huge difference. That you won't notice the services in the cloud other than maybe seeing an S3 link. But that is where ASDC, which is the parent organization to the DACs, is headed. Like I said, it's just an arduous process at times.
Thanks. One other thing I'm thinking about is in terms of funding, NASA roses or other funding proposals. If you're going to go that route, consider inviting someone from your state, your local organization, whatever, to understand their data needs. So when you're doing that project, you're going to provide something that's useful exactly for that data and user, so they can make a decision.
So this session, I think we have a 5-minute break, and then we're back in this room for the next session, the final session.